Good afternoon or morning or whenever you're watching this. We are finishing up our first lesson of this unit, of this chapter. So just keep in mind that we're still just trying to understand this new set of vocabulary and new set of types of questions that are going to be asked and new set of like variables that we use to define the vocabulary. So that's kind of what this wrapping up of this lesson is going to be, is that we're going to talk a lot about just the notation, but it ends up being a lot of calculations that we're really, really familiar with. This is going to be referencing back to our statistics unit where we needed to use our statistics in our calculator. So if you feel like you don't remember how to use the statistics functions in your calculator, I would definitely recommend referencing back to your previous chapter that taught you that and refreshing on how to use it. We are talking about probabilities of a certain event happening, right? So we're dealing now with these tables of like, this is the variable that we're looking at, and now we're looking at the probability of that variable happening, which means we're still only looking at one variable. So we're going to be using our one variable statistics in our calculator. All of that, let's go ahead and get started on our notes. So a new term that we're going to hear a lot is expected value. What it really is the mean. So we're going to calculate it exactly how we calculate the mean. In general, it's the mean of the population. So a lot of these things seem really familiar, right? We've done the fact, like how we find our probabilities in these tables is that we're finding our relative frequency. And so that is harkening back, is remembering back to our statistics unit when we had to find that. The difference here is that your relative frequency is dealing with a description of a certain sample. So we're only looking at one sample and it's describing that one sample. Whereas expected values, probabilities, and now this analysis in this way is assuming that this sample now represents the entire population. And now we can start talking about, okay, if I continue to run this experiment, if I continue to run this experiment, I expect that this will happen. And that's where this idea of expected values comes from, is that if I continue this experiment in this population randomly, I'm going to expect a certain value to happen, and that value is the mean of what we've found. So let's remember or revisit our mobile phones example. It's a couple pages back, but just as a real quick, to be able to have the data here in front of us. We had the number of phones, and then we found like the relative frequency, and then we found the probability mass function. We call that PMF. We shorten it to PMF, so you might see that. We had 0, 1, 2, 3, and 4 phones. The probability mass function for 0 was 0.015. Go ahead and continue to fill them in from your other page, or you can just write down what I'm writing down. So we want to find the expected value of this. So to show you the fancy formula that always looks way scarier than what it actually is, it is the formula that you see in your formula packet. It's represented by this variable. This variable is called mu. And it looks like that. Sometimes, like if I was a better drawer, it has like a little tail in front and then a tail at the end. We also just use E of X to represent expected values, which I think is slightly less poetic. It's not, I think math is like a poem, and I like using fancy variables in order to represent things that are really not that fancy. So here's the formula that we use. It has a sum, so we've got this really fancy uppercase sigma here, and it's every value, these guys right here. Remember that the capital X is like that one experiment, and then lowercase x is all the possible values with that one experiment. So 0 is a possible outcome, and so that would be a lowercase x, but if what I pulled out was 0, then it's capital X equals 0. So capitalization does matter, and that's why we have X's that are lowercase look a little bit fancier than the capital ones. Okay, we take each expected, or not expected, but possible outcome and multiply it by its probability of that specific outcome. And then we add them together. So 0 times 0.15, 1 times this, 2 times this, 3, 4, and then you add them all together. That's what that means, is that you take each of these situations that have been multiplied together, and then you add each of those instances as you go. Okay, we could also use our calculator here, but because as I've seen in the past, as you've seen in the past, we tend to struggle with this sigma and we get really frustrated with it, or maybe not remember what it's about. So we're just going to practice using what the formula actually says, and then we'll talk about how to use a calculator. Okay, so we're going to do 0 times 0.015 plus 1 times 0.235 plus 2 times 0.425 plus 3 times 0.245 plus 4 times 0.80. That's it. So you can see that what we've done is we've taken each x and multiplied it by its probability. And then this idea of this sigma is that you then, to move on to the next term, you add it and then move on to the next term and multiply those guys out and then add. I would like for you to go ahead and do this in your calculator on your own and tell me what you get. Hopefully you got something to 3 significant figures like 2.14. This is how we calculate it by hand. Yes, we can calculate it using our calculator. We'll go through what we put into our calculator using our statistics one variable. But as we've seen, sometimes IB questions will give us like a part of an answer that we could plug into a formula in order to find out something else. And so it really does kind of force you to not use your calculator sometimes, which is a bummer. But just so you know that this is how this formula works. Okay, let's move on. Let's learn how to use our calculator.